All right, welcome to this demo where we're going to take a look at how to work with objects using the gsutil command line interface utility. I'm using this from a Google Cloud Shell editor. However, this is basically just to make it easier with regards to authentication. You could just as well use this utility from your laptop. Works exactly the same way. Let's first check whether we have any cloud storage buckets available for us, and we do. deepdives-eu, and we're just going to check that that is empty as well. Yep, that seems true. So that's how we use the ls command, right? Now, if we want to copy over a file, this Google Cloud Shell always has a README file, so I'm just going to use that. We use the gsutil cp command for that, giving the source and destination to the command that will then move over the command, as we can see. You can see that it guessed the content type and then moved over the file. And now if I list the contents of the bucket, we're able to see that it's there, right? Now, similarly, this also works the other way around. So if we set as the source the cloud storage option, and then as the local one, I'm going to just make a copy.txt because we already have that. That makes us download the file, as you can see. And now we have two copies of the README file locally. So for this next part, I'm going to generate a random 1 gigabit file. Let me just get a sample out of the random device. This is faster than me trying to upload a file into Cloud Shell. So there you go. There we have a 1 gigabyte file. And now let's see what this looks like when we're trying to copy it over to the bucket. Now can you see that there's quite a bit of text here, and it starts to go quite slowly. And what the text here says is that it noted that the file was large. So you should be using parallel composite uploads for that. However, this is not enabled by default in gsutil. So it tells you here how to enable it. Either using the .boto configuration file. So this is the configuration file that is going to be used by the gsutil to get the default configuration. But we can also set that using the -o selector in the command itself. So you saw that took a while to upload 1 gigabyte, 32.5 megabytes per second. Okay, so let's try this command again by setting the flag gsutil composite upload threshold equals 1. I guess the main thing here is that this shouldn't be 0 because then it's off. There you can see it. A lot faster and no complaining about not using the parallel composite upload. So that's how we can set that up. And there's also a different bucket size command in the documentation. So parallel composite upload component size that will set the maximum size of the different parts, different components of that parallel upload. However, the maximum number of components is 32. Now, what is interesting is that when we do this, we could now interrupt the upload. Let's go like there and see what happened, right? So let's take a look at what our bucket looks like now. Supposed to do an ls, right? Here we go. We have the sample file, the one that we generated earlier. I think we can do an -l here. So there you can see it. We have the original sample file here, and then we have the README file that we used in the beginning, and then we have this weird prefix here. So let's take a look at what that is. 555-8299-785. gsutil, fair enough. TMP, fair enough. And as we drill down, what is it that we're getting? Parallel composite uploads. So as we did a parallel composite upload, the partial files are available here, right? So for details, see gsutil help cp, right? And then in there we should have a hash. Yeah. So in here we have one object. That is the partial stuff that was uploaded correctly. Now, what's interesting is, so if we do this again with the same command, it'll actually resume the upload instead of starting from 0. Right? So that's cool. Of course, in case you don't want these partial files to be there for longer, there is a clear way that you can access those, right? So you know where they are going to be located in your bucket, and that way you can easily create a lifecycle rule to remove them if required. Now, another example that we can do in gsutil that we cannot originally is do streaming uploads. So I could do like a, what should I do it? I do a head with the stream, right? So instead of putting it into file, I'm going to head this random. I'm going to pipe it to gsutil, cp, and then just hyphen for the standard in, and then put it into our deep dives demo bucket as sample or stream, right? And this time, the cool part here is that gsutil doesn't know the size of the file as it uploads it. So it needs to do a composite upload itself with an unknown file size, and then only at the end, once we've gone to the 1 gigabyte amount, it will then compose all of the parts into one file. So in this case, the bottleneck is actually the U random device here in the Cloud Shell machine. There we go. And now if we do an ls -l, to our bucket. Deep dives, can't even type the name correctly. We can see that the stream was uploaded in its totality. Next up, just showing you that, of course, we can do server-side copies. So if we copy from deep dives demo, let's say sample 2, deep dives demo sample 2, then this does not go via our Cloud Shell editor machine, right? This happens locally. However, we still need to pay for both accessing the data in read mode and in write mode. The gsutil utility also has a move command. So if I'm just going to move sample 2 to sample 3, this might look like a rename operation. However, in reality, as you can see from the text, it does a copy first and then it removes the original one. So there is no renaming or moving, as we should know, as object storage is immutable. Okay. So further on, if we want to take a look at metadata of individual objects, we can do that using the stat command. So that's gsutil stat followed by the URI of the object. Let's take the sample. And there you can see the current metadata of the object. So now, one of the things that we can see over here in the metadata is storage class. Now this is fixed metadata that cannot be directly edited. So what can we do to change the storage class? Well, gsutil has a command called rewrite. And with the rewrite command, we can give the storage class with the -s option that we want to use for the object, right? We can say nearline and then the object itself. And you can see that this actually results in a physical, rewrite of the object, right? So we will be basically making a copy of the object, and now the new object is going to be in nearline storage instead of standard storage. You can check that by taking the metadata again. There you go. You can even see that the creation time and the update time are now the same because we've actually changed the object itself. Also, the e tag is different, and everything. There's other metadata here, like the content type. In case we want to change that, we can use the set metadata command. And the way we do that is with a -h for header, and then we say, for example, that the content type is text plain. And then we add the URI for the object again. There you go, it did that. And now if we take stat again, you can see that we've changed the content type of the object into text plain. We can also set our custom tags or metadata onto objects. But if we try to do this like, let's say environment production, If we try to do this, that will come back as an exception, because the environments or the metadata is set as a header, and by default we can only use the following headers that have been predefined. If we want to create our own headers, we need to prefix them with xgoog meta, and then they will go through. There you go. And now if you take the stat command again, you can see that besides the normal system metadata, we also have environment production as metadata. One more trick regarding this kind of stuff. So I'm going to copy the file over into our Google Cloud Storage bucket with the Z option. And let's see what this does, right? So you can see that it's copying the file, and it's of content type text plain, right? Because it ends with .text. And what it's doing first is it's compressing the file. So this is happening locally. So it's applying gzip on the file. And then once it is done, here we go. Now once it has been gzipped, the file is then going to be uploaded. And because this was a random file, we don't get very much compression. You can see there's a roughly 20% compression only. With this, however, it's there, right? So now if we do a LSL on our bucket, this is what we get. So we have a sample.txt file that is clearly less than 1 gigabyte, right? Okay, so now what happens if I download that file? gsutil copy sample.txt. I'll make it a local copy of it, sample downloaded .text. Now you can see that when it's doing the download, it's first downloading it to a temporary gzip file, and then uncompressing it automatically. There we go. So that's one way of working with it. Okay, now moving over to the Cloud Console for a while, you can see that we have the sample.txt object here. It's of type text plain, and you should also be able to see that it is compressed. There you go. Content encoding is gzip. So now if we access this data, and you can see that it is actually shown to us in uncompressed format. Now this is due to the fact that the encoding was in gzip, and our browser actually accepts that. So in that case, our browser is able to decompress it. If we would not be accepting gzip, in that case, actually Google Cloud Storage would be doing the transformation from gzip into uncompressed and send it that way.